Well, good morning. This is Linda Shea with Drilling Contractor. Welcome to our virtual panel discussion sponsored by Schlumberger. The theme of our session today is well construction and autonomous directional drilling. So we know that there are various forms of automated directional drilling going on in our industry, but much of that automation is being achieved within individual pieces of the directional drilling process. And in order to push that automation to the next level, the industry will likely have to look a bit more broadly at the entire workflow around directional drilling. So not looking at it in silos, but more holistically from planning to execution, from surface to downhole. So today we're going to be hearing from Schlumberger about their vision for autonomous directional drilling. The goal here is not to try and achieve some kind of one-off record well. The goal is more to achieve consistency and efficiency day in and day out, something that can be sustained regardless of what kind of formation you're drilling through or regardless of who the individual directional driller might be who is working on a certain day. So our hope is that the session today will give you some food for thought as you go back to your own organizations and think about how you might approach drilling automation for the future. So with that, I would like to go ahead and introduce our panelists. First, we have Raul Suarez, who has worked for Schlumberger for 18 years in places like the Gulf of Mexico, Ecuador, Brazil, and Venezuela. Today, Raul is the product manager for drilling tools for Schlumberger. Next, we have Ziad Akawi, who has been with the company for over 13 years, serving in a variety of locations and positions. He's now part of the marketing and technology organization and champions autonomous directional drilling. Last but not least, we have Alex Short, who has worked with Schlumberger for 22 years. He has been in a variety of roles, including managing well construction operations in Mexico and assisting operators to adapt to new technologies. Alex is now the digital program manager for well construction. Well, gentlemen, welcome to our session today and thank you for being here. We're going to begin by having each of our panelists share some very brief remarks. I think we have just 3 or 4 slides to help set the stage for our following discussion. And to all of our viewers, please use the Q&A button on your screen to submit any questions that come to mind as our speakers go through their slides. I know they are very eager to answer all of your questions and to make this session useful for you, but we do need your participation to make that happen. So with that, Ziad, shall we start with you first?
Yes, perfect. Hello, good morning, good afternoon, good evening for everyone on the call. Thank you for joining us today. Thank you, Linda and the Drilling Contractor team for giving us the opportunity to talk and to discuss such an important and exciting topic for not just our industry, but the directional drilling community at large. I think everyone here and everyone on the call would recognize that our industry is facing an unprecedented challenge to operate more efficiently and sustainably than ever before. You know, we have traditionally always pushed ourselves to advance technology development to meet the demands and challenges that we face as we advance in drilling needs and ambitions. You know, it wasn't too long ago that drilling a curve meant, 5 different roller cone bits, 5 motors, 4 MWDs, 6 trips to land the basic 2D trajectories. We fast forward to today's capability where we're not just drilling curves, but curves and record-setting laterals with rotary steerable systems in single runs at ROPs that would have been unimaginable just 5 years ago. So naturally, our domain has always pushed forward the boundaries of what's possible. But recently, the pressure, I would say, have been amplified by various obvious factors. And now more than ever, technology development is looked at as the fundamental component to our ability to evolve and move past this challenging environment. So in this critical time for our industry, more specifically within well construction, bold ideas matched with aggressive investments are needed to foster disruptive innovation. And that's exactly what we're doing at Schlumberger. Our vision is to provide the autonomous self-steering BHA, where no more the days of siloed independent workflows, but rather a fully integrated data architecture that guarantees complete harmony of all the tasks associated with directional drilling. We want to provide our customers with an autonomous system that can drill all their wells regardless of the field, rig, or trajectory in the most efficient and consistent manner possible. And just like the perfect storm, of challenging world events that's encapsulating the industry. There's an equally and potentially bigger positive influence that we could draw from the recent advancements in the industrialization of cloud computing and our ability to tap into machine learning and AI solutions to drive not just directional drilling, but logging while drilling, measurements while drilling, the greater well construction capabilities in our overall oil and gas industry. So for us, the vision is clear, the commitment is solid, the technology development is in full effect to realize this new and exciting phase in our directional drilling capabilities, and it will provide a material impact to our customers' operational performance and their well construction ambition. And obviously, for such an aggressive plan and such an ambitious program, we want to extract value for our customers and for the industry, not just when we reach that ultimate goal, but along the way, along that journey of developing the technology blocks that will enable us to have that capability. So for that, I'll hand it over to Alex and Raul to kind of walk us through a little bit how we're structuring our development and how we're organizing to ensure we bring value, not just when we reach that goal, but every day as we get there.
So good morning, good afternoon, and good evening, everyone. And thanks again, Linda, for the invitation. So let me run you through those levels of autonomous directional drilling that we're going to talk about right now. So we've structured our development and roadmap around 6 key levels of autonomous capabilities. So these levels that you see on the screens, they're a shared framework within Schlumberger, and they are aligned with other existing standards in other industries. And what they do, they help us ground our development in some tangible steps, and also a map for organizational changes in the future. So let's describe those levels, if you will. So level 0 is really the level that we're the most familiar with in our current work, which is the level where humans are fully in charge with the assistance of alarm. So so that's the level that is the most common today in our industry. So level 1 and 2 is where you start seeing singular or workflow automation start taking place. So humans are still in control of the complete operation. And if we take the example of the workflow that we're mentioning here, what we're looking at in terms of features at those levels are trajectory monitoring and projection, downhole singular or multiple automation algorithms. So you can think of inclination hold, for example, azimuth hold. So level 3 is really when you start entering, moving into the autonomous world. So level 3 combines multiple features and it unifies them. And so that has some implication in how you design your system, because now it needs to support analytical decision-making together with the physical automation of the steering process. So that's where the system really needs awareness of the directional drilling workflow and help us make decisions when we still have to. So the driller is still engaged, or the directional driller are still engaged, and they ensure the system is delivering the workflow as per expectation. So level 4 is where things get even more interesting, because it's where you see the combination of multidisciplinary well construction workflows. This is, I would say, it's a bit of a specificity of oil and gas, as we have multiple disciplines collaborating at the well site and different actors in charge of them. So practically, what does it mean? So it means that in the case of directional driller and the driller, they're like two men in the car that have to continuously interact to deliver a result. And so if your system is not able to manage those workflows and the interactions with the other workflows, then this workflow will be at best suboptimal, or it will rapidly fail. At level 4, however, so the driller and the directional drillers, they're hands off and minds off, but they're still there, and the system needs to be able to manage a fallback in case they have to take back control. And finally, I think level 5 is the one we're all dreaming of, is the word of full autonomy, and that has some requirement for the system to be able to surpass what we achieve as humans, or at least match it, which is have the ability to adapt to all situations and also make decisions in complex environments. And that also means that has some implications on the way you plan your well, because the system needs to know what your intentions are, what your constraints are, in order to fulfill them. So those levels, I know we're talking about directional drilling here today, but they apply to all aspects of well construction. So directional drilling, obviously, but also fluid management, mud logging, and cementing. Yeah. So now I'll pass it on to Raul. I will explain what are the underlying elements that make building those autonomous levels possible.
Yeah, thanks, Alex, and thanks, Linda, and the IADC, and all the attendees. So when we were looking into how we achieve those levels, how we get into that one, and really how we practically go and work and organize them, so we can understand how we can group them together, how to think about it, and what we can bring to it. And that's how we came to these 4 pillars. By the way, this is something, as you're going to see on the naming, it's not really something new, and it's something that everyone in the industry can really play into it and provide in 1, 2, 3, or the 4 different pillars really something to the industry. And again, planning, we do planning on every step on our day-to-day work. The intelligent part comes into what is it that I'm using really in that planning phase. What is all the information that I can get, how fast I'm doing that information, how I'm applying that information into that planning, and using really machine learning algorithms and information from the best wells, all the different information about the mud that we use, the BHA designs and so on, then really try to bring what is the best well, at least on the planning phase, that we could drill in that area. When we go into surface automation, it's about all the different things that I have in surface. And by the way, this is sensors, this is different parts of the rigs, this is software that we use at surface, that they are going to be able to combine between themselves and without human intervention, really to provide during the execution phase the best solution that we can do. Downhole automation, and this is something that has been more than 18 years or more in the industry, is then how we enable and what we use on the downhole tools to be able to let them decide, let them work, let them as fast as they can with the best sensors that they can, with the best algorithms, and all these computing capabilities, being able to have better decisions without the need to even needing to check or go to surface and then come back down. And then finally, the execution. Paper, everything looks very well. When you go to drill the well, it's another story. There is always something's going to happen. There is many, many changes. Then how we integrate all this information with the best planning and all the information taken by downhole automation and on surface, how we can get the best answer, how we can get the best solutions to that specific thing that is happening that we didn't plan for, that we can actually use to have the best decision on steering, on ROP, on performance. At the end, what we want is to be able to provide the best well almost everywhere without really the need on, what type of a specific rig, where I am, what is the capability of the directional drilling or not. Be able to have that consistency, that reliability on our hands all the time. That's really how we do it. And by the way, even though these are 4 pillars, we need the 4 pillars again. We need them to interact. We need them to really have some kind of handshakes for them to work together and be able to provide. And that's how we organize them, and we came to those 4 pillars to be able to give this autonomous directional drilling the capabilities to keep moving, and Alex mentioned, from one level to the other.
Well, thank you, Raul. And thank you also to Ziad and Alex for those thoughts on the future of autonomous drilling and how the industry can be thinking more holistically about the path forward. So to help get our discussion going now, I'd like to first pose a question to our audience. So what do you consider as the main driver for automation and autonomous capabilities in well construction and the broader oil and gas industry? So while our viewers are pondering on that question, Alex, I wonder if you could go more into detail on the 4 key pillars that were mentioned earlier.
Yeah, thank you, Linda. So you have, I mean, the way I look at those pillars is almost going from bottom to from the bit up, right? And so the importance to me of the 4 pillars is the following: is that you have, the downhole automation, which is where you can have fast reactions, you can build smoother trajectories, you can deliver as per instructions. So ideally, if you could put all the science there, ideally we would, yeah. But that's unfortunately not possible. And the other reason why this would not be enough is that there's a lot of things also happening at the surface. So it's like coming from the bottom, going up, and then you get at the rig, and that's where you have the control of the rig, the surface automation. And that's where you need to start integrating the directional drilling workflow with the other workflows happening around the driller. So this is where you start integrating with the rig control. You're looking at things like ROP optimization, dysfunctions management, and those things that the driller does on a continuous basis. They need to interface with the rest of the directional drilling workflow. So those 2 workflows are extremely dependent on one another to be successfully managed. And then you have on top of that what we call intelligent execution, and so that's where the decision making is happening. So you need to model your objectives. You need to define how the decision making will be made, and you need to you also can start looking at integration with the other workflows that might be a bit more loosely linked to a directional drilling or drilling. And so, you can think about fleet management, mud logging, for example. And that's also where you start looking at all the wells in the vicinity, all the wells that can allow you to manage this one better. You can look at also being how much you comply with your standards. You can have more intelligent alarms, using all those channels, artificial intelligence or physics-based model in order to provide some insights to the people either at the well site or in the office. And I would say the last one is the intelligent planning, and the way I look at it is that strategic layer. And I think as you implement those autonomous systems, because they bring you all that consistency, and hopefully consistency is one of the things that will come out in this questionnaire, you can learn much more than you could before. If you have all those standard work or procedures that you're trying to enforce, but human gets in the way, trying to improve it or do it, adapt it to his own or her own flavor, then it's difficult to learn because you have 10 rigs and 10 different ways of going on bottom, for example. So the best way to learn on the best way to go on bottom or to steer well is to have a consistent way to implement that and then learn from that.
I want to jump on that because I think it's a very important aspect to discuss. The structure of autonomous directional drilling, what we're trying to do for directional drilling. We're talking about directional drilling. We're not talking about specific technology. We're not talking about specific steering tools. We're not talking about specific hole size, a specific field. We wanted to address this holistically to be able to bring the common elements of consistency, reliability, sustainability across all the fields that our customers operate in. And it was important to step back and say, okay, directional drilling gets executed on the well site, it gets executed by specific hardwares, but what's all encompassing to actually make that happen? And when you step back and really look at all the effort that goes into planning, all the effort that goes into mobilizing the right tools, the right hardware, the right equipment to the well site, trying to imagine, contingency scenarios and try to leverage a lot of the experiences we have from our personnel executing the well, from our managers, from our team. Directional drilling is a team sport, I call it. So it's a lot. And when we look at the recent advancements in computing capabilities, there's one element that I think everyone would recognize that ties everything together, and that's data. And that's exactly what we wanted to do. We wanted to tie data from planning, execution, from surface and downhole automation and execution, so that we always get the best response of any particular action or workflow that we're trying to achieve. And this is exactly what we're doing. It's no different than, the way we've been operating over the past, I don't know, 20, 50 years in this domain, right? We have experience, we have knowledge, we apply that every day, and we try to make every well better than the last. Now we're just using these new tools that we have in our toolbox to not just advance that, but to ensure that's consistent across the world.
So it looks like we have the results coming in from our polling. So it looks like we have pretty much a tie between economic factors and consistency and repeatability. Does that surprise any of our speakers today?
No, that doesn't surprise. And to a degree, they're kind of one of the same, right? Those two answers: consistency, repeatability, economic factors. Having the strengths of, or the confidence to know that the plan you planned can get executed in the time frame and within the budget that you're expecting. That brings value, not just directly relating to cost or economics in general for well construction. So I'm happy to see that it's in line with kind of what we've been seeing from our customers, and all this, it's driven by the needs that we're seeing from our customers, what they're asking us to do, and where we see their visions moving forward within well construction. Consistency, reliability, economics, they all kind of tie together. So to me, that's it's what I was expecting, and it's kind of the driving force of why we're pursuing this.
And Linda, to add something to it is, everyone knows that there is always an experience drilling a well, and you can never really anticipate perfectly what is it that is going to happen. We're going to the unknown, even though we have a lot of information. But some of the issues that everyone has is like, if I can do all the wells, or at least, something's going to happen. Okay, can you tell me on how many of my wells? Out of 20 wells, I'm going to have issues on 2. I'm going to have issues on 3, on 5, on 4. Can you give me some kind of number? And statistically, you can do it. But how can we really nail it? How can we try to give a more consistent answer to it? And then everyone could, then plan the AFEs properly, understand the overall cost. That's going to make it easier for everyone. So out of 20, you can reduce it, or I have my well planned for 10 days. How can I try to make it always 10 days? Or it's gonna be between 9 and 11, but it's not gonna be 15. It's not gonna be 17. How can I try to help on really making that number stick? It kind of makes sense. It's going to both the consistency and the economic factors on it. It doesn't surprise me either.
I think we see more and more, consistency as emerging as a main theme, and people start measuring that much more than they used to. So for some workflows, it's going to be easy. For some workflows, like directional drilling, to a certain extent, sometimes it might be a bit harder in the sense that wells can have very different constraints, and comparing them might be difficult. But still, we're measuring stuff there as well.
So I guess you guys have been urging people to step back and take a more holistic look at this whole process. So I was wondering if you can elaborate on how autonomous directional drilling will fit into a bigger well construction workflow.
I think directional drilling is quite advanced in some forms. If you look at all the efforts that as an industry we've been putting into it. Having said that, it's not the only domain where we've been working, and what we've recognized is really that there's mostly commonalities between all those different domains. And if you were to take those levels of automation or those different elements that Raul presented, they pretty much apply to most of the other workflows that in the well construction domain, and probably beyond just well construction, if you will. So we're using that same framework within all our well construction services to guide what we're building, like surface automation, intelligent execution, in intelligent planning, and beyond that, we're also using a common platform, because it's not only about using the same framework, but it's also about making sure that what you do on drilling fluids will have an impact on the other activities at a well site, and you need to recognize those dependencies and effectively update your model in real time as you do so.
Yeah, and that's for me, we're describing holistically directional drilling and the need to tackle all aspects together and tying it together. And the same thing applies within well construction. I mean, Alex hit it right on the head with respect to needing to align with other workflows. Directional drilling is just one part of the greater well construction activities that happen on the well site every day. So it's important as we move forward, that's taken into consideration within the architecture of these specific systems. To give you an example, the common platform that we're utilizing within well construction is it brings together fluids, solids management, mud logging, measurements, logging, drilling, so that data and insights and connectivity can be utilized to enrich the well construction process. And I think this will happen in parallel, as specific domains advance and as these capabilities evolve, you'll start to see them converge, because at the end of the day, if we drill the best directional wells or reach the best directional objectives, but fail to, manage fluids properly or fail to protect the integrity of the well itself, we ultimately lose as a collective team on that well construction project. So there's no doubt about it. We've done this always. We work as a collective team, whether it be the rig provider itself, the various contractors, everybody involved. It all comes together. And it's, for us at least, we're making that investment within our capabilities to ensure that when we do have automated fluids management, that data gets utilized properly within other workflows to enrich that workflow with insights and intelligence, so that we can succeed, all of us together on within well construction.
And by the way, this is something that we're seeing outside of the industry. Everything talks to everything. And how that interaction really works and shares information and work together. That's how really you get the best. So if we get that to the oil and gas industry, if we don't do the same, we don't really bring all that capability. And again, some parts might be a little bit easier or ahead than other ones, but all of them needs to get together. And we don't do it, we're gonna lose a huge of an opportunity to really get the best out of it. So even if you have pieces, everything should go under a complete mind of well construction, how you can improve it, how you can get it better. So that's a great time to actually do it and think it in that way.
So I was wondering if maybe you guys can talk a little bit about the drivers and expectations for this autonomous directional drilling project.
So the drivers, I think it's clear based on the question, right? So it's what we're hearing from our customers. What our ambition is internally to drive not just directional drilling workflows and domain, but overall well construction. I think anybody that's been associated within well construction, and more specifically within directional drilling, has always looked at or sat back and thought, hey, there's a better way to do this, or there's, why are we doing this? Questioning the status quo. That's honestly one of the main attributes I put to, not just us, but anybody within the oil field. My days in the rig, everybody questions everybody. And that's, I think, a very positive trait. So I think, the motivation is to bring consistency, is to help with well economics, to reduce the cost per foot drilled, to help with productivity index. We didn't touch too much on it, but level 5 really aims to not just have complete autonomy for the directional drilling workflow, but to integrate formation evaluation data, LWD, geosteering. Is the plan that we planned even relevant once we start drilling? Those are the kind of things that are really going to drive economics benefits for the drilling process and for the overall return on investment for that particular well, improving productivity index while drilling. So the motivation factor for me are simply those, is to help our customers reach their well construction ambitions. We're being forced to, not being forced, but we are collectively as an industry, driven to be more efficient and to be more sustainable. And I think they come in hand in hand. So for me, that's kind of the driving force of why we're pursuing this. Yeah.
So we have a question from a Catherine who's asking, as of today, which level is Schlumberger capable of for autonomous directional drilling?
Yeah, so for autonomous directional drilling, like I mentioned, this is going to be a journey, obviously, to get to the ultimate ambition. And this is, I think it's important to state that not one level is better than the other, right? It really depends on the challenges and the ambitions for that particular drilling program or that particular operator or that particular field. So, to give you an example, maybe a specific well in a specific basin is more than okay with having capabilities around level 2. And then you can go to maybe a very complex, challenging environment where it's a necessity and not necessarily a want or a nice to have, but a necessity to have fully automated systems like within level 4 and level 5. So I think it'll vary depending on the needs of that particular field, that particular customer, what's required to really to provide the economics of drilling, consistency, reliability, all those great things. So that framing that today with what we have in taking advantage of the building blocks that we already have in place to get us to that ultimate ambition of capability, Schlumberger today stands around level 3 and level 4, depending on the particular field and the particular deployments that we have. So with that, providing directional drilling on its own within either downhole automation or closed loop surface-based systems between level 3 and level 4, that's where the really intelligence kicks in. And that's where we stand today in various deployments.
Linda, I need to add something on this one. So we know that people think a lot of in the automotive industry, and we know that the automotive industry is gonna see a major shift once the vehicles get into level 5. But that's not going to be our case in well construction. I think our major shift is going to happen in level 3 and 4, because this is where you can start automating parts of the workflow. You can start doing more operations remotely, etc., etc. Ultimately, going from level 4 to level 5 is going to be, in terms of impact, a much smaller step, I think, in terms of value for the industry as in the automotive. So I think it's the good news for well construction is to realize that we don't need to wait to be at level 5 to harvest most of the investments that we're making as an industry.
Sorry, Linda, let me also add to that one a little bit. One key thing also is the way we're looking at it is that it shouldn't really matter. So one thing is what you need, is kind of what Sia mentioned, but another thing is, maybe I'm an operator on a land rig, and then say, maybe I'm not a fancy offshore, so most probably I'm gonna take, I'm gonna stay only on level 0, level 1, which is not really true. What we want, what we are really trying to do is have the possibility that we could deliver these levels of automation on lag rigs, on offshore, on horizontal, on vertical. It doesn't really matter the whole size. It doesn't matter the technology that you're using. So if I'm using motors, if I'm using rotary steerables, if I'm using advanced steerable system, you should be able to have that capability. So that's the way that you could really, give the benefits almost to everyone. Of course, it's going to depend on maybe their need, maybe, how much information I'm having, how many tools I have down holes, and how much information I'm gathering. But at the end, that capability should really be to every hole size, every well profile, every type of rig, really to get that benefit out there. and everyone should feel, I have that importance that I should be able to get these levels if I need them.
And that's why I think, when I mentioned our ambition is to basically be able to provide a system that can drill any well, regardless of the field, rig, or trajectory, is we did not want to tie this particular capability to any one steering system or any one requirements for, say, a particular rig or environment. So this is, I think, is very crucial when we say we're actually looking at it and addressing it holistically or from a higher level. So we wanted to be able to give our customers the option that regardless where they're operating, they could leverage some pieces or all the pieces depending on what they need, what they want, wherever they want. And we're not going to necessarily limit that just because you're on a land rig or versus an offshore rig. We want to be able to do that with the most advanced rotary steerable systems to the most basic positive displacement motors. Directional drilling is directional drilling. What tools you use, that's really up to us to figure out the best solution for that particular challenge.
So we have another question from Clint, who's asking, with independent drilling contractors currently operating most drilling rigs that are drilling today, how do you envision Schlumberger integration with the various rig control platforms currently owned by drilling contractors and or other equipment providers?
So this is an excellent point because, like I mentioned, well construction is a team sport, right? So it encompasses a lot of different players, a lot of different capabilities, infrastructure, investments. So for us, really, we wanted to focus the bulk of our deployment to be as minimally intrusive as possible to everyone else. So what that means is we wanted to have the system to be able to deploy it without necessarily putting undue stress on, say, drilling contractors or the drilling rigs themselves, or disrupting kind of their typical workflows and their systems overall. So for us, we envision, depending on certain levels, like for example, level 3, it's totally independent of the rig control system, and we'll have this process to be able to facilitate the intelligent execution in advisory roles of, say, the steering process itself, with some automation of the downlinking or steering mechanization itself. But then you jump into level 4 and 5, where as you advance in these capabilities, no doubt there's going to have to be cooperations with the rig providers, with the rig contractors, interacting with the rig control systems, and doing it in a safe and effective manner. Data privacy, fail safes, ability to not disrupt systems overall. This is where I think where Schlumberger has been investing heavily within drill ops, to be able to play that role as an automation system layer between, say, the workflows for well construction and for the tying into rig control systems with the rig providers. So I think depending on the level, depending on the needs, there's definitely going to have to be some teamwork. There's definitely going to have to be a drive for everybody to push this forward, because the only way we're going to succeed as an industry is if we work together. And this is, there's no doubt about it. We're going to have to work close together.
So Colin is asking, what would constitute the capabilities of a candidate rig to participate in level 5 of autonomy?
So I think it's, to put requirements on what would be required to reach level 5, or what would it be to enact level 5. In reality, if you go back to the basics, we said data, connectivity, and insights. That's really what's going to tie everything together to allow us to do this. So when you look at the pillars, we said intelligent planning, which is kind of independent of the rig. It's really leveraging data and insights to ensure the best plan is done for the execution phase. We talked about surface automation. Depending on, say, if we're talking here level 5, we're talking some sort of automation layer that's interacting with the rig control system. For downhole automation, really downhole automation is where the magic is going to happen. For steering, whether it be for formation evaluation, the advancements in geosteering, the BHA architecture is going to be to a point where the intelligence to redefine the geosteering objective or the plan itself, or to have a closed loop steering mechanism that drives off of that, it's all embedded downhole and is independent of the rig. So as you advance and using that data to drive directional drilling, that's independent of the rig. And then as you drive, things like drill a section, drill a section in objective automation of the rig itself, that's where the automation system comes in, and that's where it'll be heading. So there's not going to be a huge requirement on, say, updating rigs or requesting, something that we don't have today. In reality, the pieces are there today, is just connecting them and ensuring they work, safely, consistently, and properly together to reach that vision.
Yeah, generally, Linda, when you look at getting to level 5, there's one requirement is normally you would expect the rig to be an ACBFD rig, and then the interface with the rig control system needs to exist. But we have this interface developed for most of the rig control system in the market. But yeah, I think that'd be, if you have a pure mechanical rig, getting to level 5 is a bit probably optimistic.
Okay. And we have a Holder. Sorry if I'm mispronouncing your name. He's asking, you're driving for fully independent remote control of well placing. In other words, the aim is to enable autopilot functionality on drilling rigs. How do you intend to overcome the barrier that the plane or the drilling rig doesn't belong to you? What could be the solution to turn this into a win-win situation for all involved?
I think this is kind of in line with the last question that we answered, and I know Raul's itching to jump on it, so I'll let him jump in as well. But I will say this, right? If you look at directional drilling, and if we're talking directional drilling, or even logging while drilling, when you analyze what we're actually doing, 80% of the activity that we do as, say, at directional drilling are all analytical tasks, analytical decision making. There's not a lot of necessarily buttons to push or levers to pull to execute directional drilling steering. You might argue, okay, steering a positive displacement motor versus downlinking. But in reality, a lot of what we do, and some people would call it an art or a science, it's experience, it's ability to anticipate the steering response with the formation, with the BHA, how do we stick to plan, the projections, the mathematical calculations needed to ensure that we reach the next target and we reach TD as intended. A lot of that are analytical processes. So there's not a lot of mechanization we need to do or interaction with the rig that's substantially different than what we do today. So I think this is the important part, is that, like I mentioned in the last question, there's not going to be a big difference in terms of, we need to redesign everything, the control system we use on the rig, the equipment. That's not going to be necessary. And in fact, I think they'll complement each other. You're not going to have, intrusive workflows anymore. And it's all going to be kind of approval roles. Like, for example, to send a downlink, the driller will just see it pop up, and it's in his decision space to say, yes, go ahead, execute the downlink or not. Drilling parameter optimization, all those things are going to complement what the rig systems are doing, and not necessarily take over or be kind of a push-pull kind of scenario. I think it's going to complement how we work today and advance it further.
Yeah, Linda, I wanted to jump in. And it goes back to that one. We've been working together with rig contractors for many, many years. The only thing is that, maybe some of these ones, let me connect to the pump so we can, to the control system so we can rotate differently, or we can send a downlink command. That's, of course, that was seen as very mechanical, only one step. But if you keep growing into that one, it doesn't need to be, who takes cover or no, it's just more processes and more. Of course, there needs to be collaboration between the two of us on, okay, what can we implement, what do we need to do, and the rest is how much we can use of that data to really improve and use it. But it's not really that different. It's just more steps, more parts, more parameters. True, but it's just adding to what we have. The other part, maybe we saw it a little as maybe small, or it's just a mechanical part, but it's really actually the same.
And we have a question from Oscar, who's asking, His question aims to the client perception of this technology, because one of the most important synergies in the directional drilling work is the relation with the client. So how can we keep a stronger and trust relation with the client without any crew on site?
So that's an excellent question, and I think it's a mixed one between the actual directional drilling workflow, or the autonomous vision capability for that workflow, and remote operations, or what we do across the world with Performance Live. I think if anything, this amplifies that collaborative environment and enriches the customers with more real-time data and insights on what's happening on their well sites and what the decisions are actually taking place. You know, a lot of the motivation behind, you know, I would say one of the components in our intelligent execution is the directional drilling advisor, which holistically looks at, you know, what needs to happen from the minute we start drilling to the minute we TD. And a lot of that data and insights that's generated through that system that to help the DD do their job much more efficiently is also used to transmit insights and information, KPIs, to all the stakeholders within directional drilling. And again, I go back to this team sport analogy. Directional drilling has a lot of stakeholders, one of the main ones being obviously the drilling engineer responsible for the well and the client themselves. So I think what we've personally seen on leveraging this technology so far is they love it. They're able to see what happened on every stand, on every joint, the sliding efficiencies, the steering responses, a lot of the questions that used to happen kind of in the doghouse in the company man's shack. And hey, what's going on? Are we going to land this well? We're going to have to come in short. Let's talk to the geologist. A lot of this that was driven by, you know, experienced and trusted professionals are still going to take place, but they're going to be enriched by transparent KPIs that's real time and accessible to all stakeholders. So if anything, I think this bond or this need to make sure the stakeholders are aware of what's happening within the steering process is only going to get better, and it's only going to improve everything. And so far, the response from the customers that we've dealt with, that's one of the best things they actually love about the system is those the transparency of the decision space within steering.
And Linda, it has taken time. And by the way, we need to, you know, remote operation has been used in the industry for a long time, but it's, you know, now, okay, you know, 65% of all the wells are drilled with some type of remote operation. So, you know, to get to 65%, that takes a lot of trust, a lot of understanding the process, a lot of, you know, let's go and build it together. And by the way, many people are doing it in many different ways also. On try how to get to that remote operations, but also has to do on how we enable, how we help precisely the customers on, you know, how can I help you in taking one part of the task or put it inside of the autonomous directional drilling so you can maybe focus or more on some other things that you want to look at it. You know, when we were looking into downhole automation, one of the things that we want is, let me take that out. Let me take that kind of question. Let me help you. And that's one of the things that we're seeing. You know, not too long ago, we started on something that we call the auto curve, which is the capability of drilling the curve automatically downhole. That's something, you know, completely new, no interaction from surface. And what we have seen is that when we do that, even the directional driller doesn't need to think anymore about how I'm going to steer it. So he really focused himself on how can I get the best ROP? How can I drill it as fast as I can? So you're taking, you know, kind of worries or decisions from and you take it on the system so they could do it. And the same you can do slowly on different parts. And then you can help the customer on what is the most important part? What is the part that I can help you the best? Some of the other decisions, you know, we can do it inside of autonomous directional drilling. What are the ones that you want to take? What are the ones that you want to participate? And it's kind of a process, how you build it, how you go through it. And that's a key. By the way, Oscar's question is totally right. That communication, by the way, is with the customer, is with the drilling contractor, is, you know, everyone has a play into that complete journey.
And Linda, I'm actually going to jump and take one question because I saw one that really made me happy. It's, or I think it's important to address. So it's from Mike Etrell. It says, do you see it being viable to implement autonomous directional drilling with conventional bent motor, bent motor steering assemblies? This is, this is, I think, dear to my heart because I think when we talk about directional drilling, people always assume that you're going to jump onto the latest steering technologies. It will be limited to, we said no. When we are addressing directional drilling with autonomous workflows, we want to address directional drilling. That means bent motors, that means straight motors, that means RSS, that means ABSS, that means 8.5, that means 12.25. It doesn't matter. We want to address the directional drilling workflow. So to answer your question, completely, motors will take advantage of what we're doing here. And in fact, it's not going to be a requirement. It's going to be essential because when you look at directional drilling, regardless of what whole section you're in, you might be using a bent motor in one particular section. You might be using a rotary steerable in another. So it doesn't make sense that we limit our technology to a particular steering capability or particular steering technology. We're going to make it applicable for the entire well to get executed. So I want to make sure that that's clear. So yes on motors, yes on rotary steerable systems, yes on ABSS.
So John is asking, how do you see the autonomous workflow handling all parties, service companies, drilling contractors, operators, especially in real time?
So this, you see, these questions all kind of align in the same way. How are we going to work together? How do we manage the workflow? And I'll kind of say the same thing that we said in the past couple of questions, because I think we kind of answered this already, is that I think data insights and connectivity within just the directional drilling workflow is going to improve that collaboration effect that we've always done. The communication, the transparency of the information, the data to showcase why a particular steering decision was taken, that's all going to be amplified. So to kind of repeat myself from the last questions, I think this is only going to amplify that ability to collaborate and ensure everyone has the data they need to do their job within that workflow or within well construction activity. So, and that's our aim is we want to be inclusive and drive insights for everyone to do the best job they can.
And Linda, when you see, many companies or almost every company has something to provide and to work in. If you see the 4 pillars, some of them are really gonna be able to provide something more on one specific pillar, or 2 or 3 or 4. So this capability of working together, it is a need, and it needs to happen. How much information we're providing it, where we're getting it, how fast we can do it. This is something that we need to work together and collaborate to be inclusive, as Cian mentioned. That's how you can really get the best well that you can do.
Yeah, so that has some implications in the way you develop and design your system, so that it can be agnostic of the service you're using or the rig you're using. So that's obviously something we're focusing on, but as an industry, we should all be doing that in the way we design our systems so they are able to interface with a rig control system that is not under our control, for example. Yeah.
And we have a question from Anar, who's asking, what kind of telemetry are you intending to use for autonomous directional drilling? Are you relying only on wired pipe, or would it work with mud pulse?
So let me take that one. If you go to the initial conversation that Cian mentioned, we want to be open. Do we want to include wired drill pipe? Yes. Do we want to include a pulse? Yes. Are we including EM telemetry? Yes. So it shouldn't matter which type of telemetry you're using. Again, wired drill pipe is maybe faster than other ones. Sure, but that's just a characteristic of that telemetry. But we should be able to use any type of real time and then get that information from downhole and have the better decision. It should not take you out because you don't have wired drill pipe. No, it should be every type of telemetry.
And today, today with some of the deployments we have, we're using EM telemetry, we're using mud pulse, we're using a mix. So it's like Raul said, it's just another mechanism, and it's not going to constrain the system.
And we have Paul asking, you talked about the improved consistency of autonomous directional drilling. Do you have any numbers to show this or KPIs?
Yeah, I mean, so far we've seen some amazing results. If we start off from the intelligent planning, where we leverage our predictive steering workflow to advance the execution confidence and planning optimization for the trajectory and operating parameters. On over 100 wells, leveraging that capability, we had 0 unable to follow trajectory events, which was the primary motivator to develop that particular capability. So that when we plan the trajectory and the operating parameters to reach that in execution, the confidence of the crews to actually make that happen increases dramatically. And in the driving force behind that was to say, okay, what can we do to minimize unable to follow trajectory events, to minimize disruptions to our customers, so that way when we plan a trajectory with particular dogleg, with particular tool face, with particular operating envelope, could we actually execute that as intended? And over 100 wells so far, and the answer is yes, and the data is there. You look at surface automation, where we leverage our digital acquisition system on over 750 wells so far this year, accumulating hundreds of thousands of low rotary table hours. The efficiency gains in terms of the modern UX, the data transmission from well site to town has been unbelievable. It allowed us to improve our well site crew models to help align with some of our customers' objective in terms of sustainability and in moving to a smaller footprint. That's been tremendous, and over 25% improvement in efficiency gains. I'll let Raul talk about downhole automation, because that's been a huge one for us in terms of showcasing those numbers.
Yeah. So I guess the overall KPI that we want to achieve is really, how we can lower, the dollar per barrel, dollar per foot. That's the ultimate goal. How to get there? Then we go into the specifics, and then we try to get, how much we can get on the planning, as he had mentioned. I want to make sure that I can deliver the dogleg before I drill the well. I want to make sure that I don't get to that one. So that's the able to follow trajectory a factor. In some other ones, okay, how much can I decrease downlinks? And some of the things that we have done downhole, now we have decreased up to 75% the amount of downlinks that we need to send to the tool. In other cases, how much our ROP improvements are we getting? So depending on the specific feature that we have inside of those pillars, we're measuring exactly, okay, how much am I providing? But really, as you start adding them up, the overall will be lower the cost per barrel, $1 the cost per foot. That's really the ultimate goal.
Well, unfortunately, it looks like we are running out of time. So if we didn't get to your question, I think our panelists have agreed to look at them after the event and get back to you with an answer. And if anyone has any additional questions, you're welcome to send them to us at editor@iadc.org, and we'll pass them along to our panelists for consideration. So with that, I'd like to thank again our sponsor, Schlumberger, and also our panelists, Raul, Ziad, Alex. Thank you all so much for being here. I'd also like to thank our viewers. I hope everyone is leaving this session with some additional perspectives on how you can approach autonomous drilling for the future. So thank you. I hope to see you at our next virtual panel discussion.
Thank you, Linda.
Thank you, Linda, and everybody on the call. Appreciate the positive engagement.